All right, Algebra 2, here's the deal. I just kind of looked at the assignment and noticed there were a couple problems that I had to change. Mrs. Nelson will be changing it for period 2, but period 1, you got away from me. So period 1, this has already been changed in your calendar. So here it is. Just take a look. 15. Sorry, this is even wrong. Let's try that again. 15. We're not going to do 16. 17 to 22 all. Okay. And then try these three, 27, 28, 29. Okay. All right. And you will have some time in class to finish these three. Period 1, that's you I'm talking to. I'll tell Mrs. Nelson that. All right, here we go. So here's the deal. I've got a little message from period 1 to try number 21. And 21 looks like this. Hang on, this is too much for you to look at. So let's go like this. Okay, so in 21, they say, solve this system where you have an equation with an x squared, so that's a parabola, and you have an equation with another x squared, so that's a parabola. So two parabolas. What can they do? They can intersect in two spots, one spot, or not at all, okay? Then I looked at this one. And when I looked at this equation, I noticed it was already solved for y. So I went with course substitution. So I call this home because I'll come back here later. I'll put an x in, I'll square it, I'll take away 1. All right. This is home. This is what y equals. Put this y value over here in for y, and notice in front of y is negative, so this is going to cause you some trouble. And here I go. So I go -7 equals negative x squared minus x or minus y. So here I write it, -7 equals negative x squared minus whatever y is. Well, y is over here, x squared minus 1. Then I run the negative through and get this. Then I look and I go, I got x squared, I got x squared, I got like terms. What's a negative 1x squared and a negative 1x squared? Well, that's a negative 2x squared. Okay, now I got to solve for x. Well, the first thing I'm going to do is get rid of addition or subtraction, but here I have addition. So -1, -1. So when I subtract 1 off of this side, I get -8. Then I get negative 2 times x squared. Well, get rid of your multiplication by division. So divide by -2, divide by -2, and of course, -2 goes into -8 4 times. So x squared equals 4. I'll take the square root of both sides. I'll get how many answers? 2. +2 and -2 are the solutions. All right. Now, the fact that you're getting 2 solutions, I wrote over here, it looks like 2 intersection points. Okay, and you can already see I already have them, but I'm going to cover that up a little bit. So there's 2 intersection points. One of them is going to have an x value of 2, and the other one is going to be -2. Well, how do I get these y values? Well, let's take a look. Remember, when you know the x value is 2, go back home, put it in here, and square it, and then subtract 1. Well, I did the work right here. I put the 2 in, I squared it, -1. Well, that's 4 minus 1, that's 3. Okay, then I put the -2 in, and I did the work here. -2, square it, which is 4, -1, which is 3. So they're both 3. So it looks like 2, 3 and -2, 3 are the solutions, okay? One thing I want to show you is if you thought about this problem right away, you probably knew there were 2 solutions because look at this equation, y equals x squared minus 1. Isn't this basically your parent down 1? So isn't it going to go right 1, up 1, right here, okay? And continue, go right 2, up 4, you're right there, left 2, you're up 4 right there, and I think these are the answers, by the way. Okay, now, what about the other one? Well, the other equation, -7 equals negative x squared minus x minus y. If you solve for y, I'd push the y over, I'd push the -7 over, you get this look. Well, this is your parent upside down, going through 7 on the y-axis, right? Up 7. So there it is. Right one, down one, left one, down one. You can kind of already see there's going to be two answers. Okay, and then when you go right two, down four, there it is. Left two, down four, there it is. And there are the solutions if we were graphing. And those solutions, of course, are 2, 3 and negative 2, 3. Okay, so just a little quick insight on graphing, how graphing can kind of tell you there's two answers. All right, now this is a new problem that I added on. So period 2, you probably tried it already, but period 1, you didn't even know about this. So here's the system that they give you. This is number 28, guys. And when you look at this, I mean, you could do substitution, but this section that says do elimination. And I like the way they wrote it in the book is not the way I wrote it. I wrote it like this. I just pretty much lined up all my terms. And I'm telling you, I have an x squared term here, but I did not have one in the other equation. I have an x term here and an x term here, a constant with a constant, equal with an equal, and a y with a y, right? Now, did you notice your y's are opposite? That's what the elimination wants. The elimination method wants you to have opposites. So we've got it. Let's do it. Add the two equations. Y plus negative y makes what? 0, right? And then these constants add up to negative 3. These x terms add up to 1x. And this with nothing makes the same thing, right? All right. So I have a quadratic equation. Now I got to solve it. One thing I'm going to tell you is I don't like that it's negative. I'm talking the x squared term. So what I did, and you can do this anytime you want, I just divide by negative 1, and I'm talking every number. And when you divide by negative 1, it just switches the signs, and there it is. So now I'm going to try factor it. Well, here's the deal. I'm going to show you really quick. It isn't factorable. Okay, so you know you have a positive, so it's got to be a positive times a positive or a negative times a negative. The reason I put negative negative is because the middle term is negative 1. All right, now you know you can put factors of 3, so you could put a 1 and a 3 here, or a 3 and a 1. But either way you do it, the inner, outer will never add up to negative 1. So it's not factorable. Okay, so guess what? It's a quadratic equation. You can either complete the square or you could quadratic formula. And you should be wise enough to say, hey, 3 is not perfect. I'm not completing the square. Plus, this is odd. I'm not completing the square. So you know what I did? I did the quadratic formula. And there's my numbers, right? Opposite of b, 1 plus or minus b squared minus 4 times a times c, all of it divided by 2a. And bam, that's what I got. And there, I got to this point right here and I knew to stop. Sorry, you couldn't see that. I got right here and I said, I got to stop because I have the square root of a negative, and square root of negatives create imaginary answers. So there are no real solutions. And if there's no real solutions, and then I wrote, so there's no what? There's no intersection points. So what's the answer to this problem? There is no answer. Okay, there is no solution. So what does that even mean? It basically means this. You have a parabola, and I don't really know how it looks, but it's going to go down. Okay, and then you have a line, and the line is going to shoot by it somehow like this, but it's never going to touch. So there is no solution. I mean, this, if you did graph it, you'd get something like that. Okay. All right, guys. I hope this helped you for number 28 and number 21. Period 1. There are 3 problems that you didn't do, but you'll get some time in class tomorrow. Okay. Hopefully everything's going okay.